Okay, this is the last video for Chapter 1. This is some material about object-oriented programming that is not in the book, but is always usually covered for a good introduction to object-oriented programming. And so we have two main topics. The one is we're going to call composition versus inheritance. So we've just shown you inheritance, and I have inheritance here as an example. So suppose we have a date-time class that can create objects that represent a date and a time. So internally they store the year, month, day, hour, minute, and second. And then if we want to, say, make a calendar where we represent events on the calendar, we might have a name for the event that we add, but we can just derive it from date time. So an event is just a specific date time with a name associated with it, which would be the name of the event. So that's inheritance. But whenever you do inheritance, you should also think about another choice, which is called composition. And the example on the left is composition. So we still start out with date time, but when we make a new class, we decide not to inherit from date time, but just include when the date is as a member, an instance variable, as part of the event. So here, the event object has a date time as an instance variable, and in this case over here, event is a date time type, so it just extends it as a subclass. So this is always a choice when you can always do just the object as a member of the new type of thing you're creating, or you can inherit from the thing. Now, when would you use each? So first of all, this is called a has a relationship. This is called an is a relationship. So they're related, but in different ways. So the question is, if you do an event on a calendar, is that really considered a date time? And you could argue that maybe it is and maybe it isn't. So how closely the statement that this is a date time is whether you should do inheritance or not. For composition, they don't have to be closely related. It just has to be useful that an event has a date time as part of its data inside the object, and then you would do the has a relationship. When you're actually designing object-oriented programming, if you have a lot of different objects and they all have a common property, that's something you might consider as making that a superclass of several objects. And we're about to look at something like that, which is a very strong relationship. So is a is an actually stronger relationship than has a. It's a little less strong in terms of the connection between two different objects. So now the last example, we're going to talk about the concept of polymorphism. So polymorphism relates to you tell a bunch of objects to do the same thing even though they're apparently different types of things. A good example of this is in the whenever you do inheritance from the object class, you inherit this string method. So the string method is inherited from the object class automatically, so when you can create any number of objects, and you can be guaranteed you can call string on them because they're already defined in the object class. It won't give you an error and say string is not defined. So that means that any object you have, you can tell it to convert itself to a string using the str, and in parentheses you put the object in it, and it will convert itself to a string and return something. So that's an example of polymorphism. We're going to look at a made-up example I called the barnyard example. And what we have here is we have a superclass which is called animal. And remember, in superclass is always more abstract than the subclasses. And in some cases it's so abstract it's not useful by itself, and we'll show you what we mean here. So we have animal as the superclass, and then I indented a bunch of subclasses that are all going to be derived from animal. Now animal will have a name as a instance variable, and it will have a method you can call called speak. And then cow, pig, and cat will also have speak, so you can see that speak is common to everything. And this will have to do with polymorphism. But cow has some special methods. It has chew, and cat has purr, which the pig doesn't have, and the cat doesn't chew, and the cow doesn't purr. So when we look through here, here's the definition of animal. So it has, and this just shows you a short way of doing it. Whenever you do a one statement for a body of something, you can put it on the same line like this. So the init method will set the name of the instance variable for animal, and when you call speak, it returns a period because an animal is too abstract to have a sound. So I just put period, meaning it doesn't know what it's saying. And we'll show you the code I wrote a little later. I even abstracted the name. And then we have string, which returns the name and what it says. And then we have get name, which just returns the name. So these are some common things. So because all these other methods are derived from animal, they will have speak, string, and get name all common to them. Okay, now cow is implemented from animal, so it's a subclass of animal. So it automatically gets the speak and the string and the get name. So the init for cow, there's nothing new for it to do, but it does have to call the super init. So it passes the name to the super initialization method. And then it defines this unique thing just for cows that chew. So it says munch munch. And then it redefines speak. So there's a unique speak for cows. It returns moo. So you'll see in pig, we also define speak, and it returns oink oink. And for a cat, when we call it the speak, it says meow. Okay. So, but you also notice for cat, we have another method called purr, which none of the other object types have, which prints purr. And so there we go. We have a barnyard. We have some methods that are unique to the animal, and we have the speak method, which everyone has. So this is useful because you can make an array, or in Python terms a list, and we can create all these objects of different types and mix them all together. So I have one cat named Puss, an animal named Sloth, a cat named Spot, a pig named Babe, and a cow, two cows, Betsy and Jackson. And so you can write a loop that loops through this list and ask them all to convert themselves to a string and print themselves. So they would print this out. So you can see that speak works perfectly. You're calling the same method across supposedly a bunch of different types of objects, and that's the whole idea of polymorphism. And we do this because they have a common ancestor, in this case where animal defines speak. So anything derived from animal will automatically be guaranteed to have speak. So let me go to my example and I'll introduce one more idea. So I have the same thing here. I just refined it a little bit since I did it last semester. So instead of a period, I put a question mark for when an animal speaks, because it doesn't know how to speak. And and then cow, pig, and cat are the same as the example. And my array is a little different. For animal, I don't give it a name. I just put in a bunch of dashes. And I renamed this cow Bo. So we have the cows are Betsy and Bo, and the pig is Babe, and the cat is Spot, and the other cat is Puss. And so we loop through the animals, and we'll see it does the same thing as similar to what the example in my other one is. The only difference is the animal now obviously doesn't have a name, and it doesn't know how to speak, but it does do the method speak, and it outputs that information. So let's look at something else. Let's suppose we ask all the animals to purr. What will happen? So I'm going to modify this, and I'm going to ask each animal. So I'm going to say print A. Let's see, purr. What is purr? Purr does a print. So we don't need to do a print. We're just going to, for every A in animal, A dot purr. And what do you think is going to happen? Well, you can think about that for a minute. So let's go ahead and run it. I'll show you what happens. So we get an error. It says attribute error, animal object has no attribute purr. So it prints the cat, so that purrs, and you'll see it says purr here. And then it calls animal object to tell it to purr, and it gets this error. So this is an example of not having polymorphism, where you have a bunch of objects and you're calling a method on all the objects, and some of the objects don't have that method. So is there a way we can at least make this to work? So what we want to do is, as we loop through, we only want to ask animals to purr if they can do that. If they can't do that, maybe we ask them to speak or something else. So let me go back to the IPython thing we have. So I did the same example here with purr, and you'll see it gives you that error. And the error in IPython is a little, there it is, animal object has no attribute purr. So it's the same error. So what you can do is use a special built-in method in Python called isInstance. This asks, is A an instance of the class cat? And if it is, then you know it can purr. So if A is an instance of class cat, it prints the name, followed by, it tells it to purr. If it's not, it does the else, and it prints the name, and it says it can't purr. So let's copy this code. So you can see that you can use isInstance to check if something is an instance before you run it. So put that in there, and what you'll see, we'll run it. So it gets the name of everyone. It says puss purr, an animal which is no name can't purr, Spot purrs, Spot's a cat in this case, Babe can't purr because it's a pig, and Betsy and Bow can't purr. So isInstance can check if a variable you are passed in is an actual instance of something you're expecting. Now when you do the fraction class, it's optional, but you can check if, when you're adding two fractions together, that the other fraction you're passed is an instance of a fraction, because you may not even want to try adding them together if it's, say, an integer or a string. So what you do is you check if isInstance the number you were passed in, the other fraction, and if it's not, what you're basically going to do is test if it's not, you would raise an error. So there's an example of that. So this is it. This concludes the videos for chapter 1, and we'll be working on the videos for chapter 2.